Good morning, everybody. In this video, we'll calculate the numerical value of the escape velocity of the Earth. First, let's try to understand what is the escape velocity. Let us consider this is the Earth's surface, and we have an object here on the Earth's surface. If we throw this object, let us call 1 meter per second, it will come back to the Earth's surface. If we throw this object at 2 meter per second, it will go to a further height and it will come back again. If we throw it at 5 meter per second, it will go a little bit more height and it will come back. And if we keep increasing the speed of the object, then the object will go to a very, very far distance and it will never come back. So the escape velocity is the velocity of an object at which, if the object is thrown, it will never return back to the Earth's surface. And remember one point here, the object can never go out of the gravitational field of the Earth, because the gravitational field of the Earth extends to the infinity. So now let's say, I'll do the calculation later. The escape velocity is 11.2 kilometer per second for the Earth. That means if we throw an object at 11.2 kilometer per second, the object will gradually go slow down, and it will keep slowing down forever and forever and ever, and it will never reach to the zero velocity. It will always be slowing down, and forever, and it will never return to the Earth's surface. And if we throw an object greater than 11.2 kilometer per second, or let's say 15 kilometer per second, then even it can keep going down forever and ever, and will never return back to the Earth's surface. So the escape velocity of the Earth is the minimum speed at which, if an object is thrown upward, it will never return to the Earth's surface. And here, when you do the calculation, we'll completely ignore the atmospheric friction. Okay, so let's do the calculation. First, how do we derive the escape velocity? That is simple, quite straightforward. I'll do the calculation right here. All we have to do is the total energy conservation. The total energy of the object will never change. So now let's say we have to find out what is the total energy of the object at the ground or on the Earth's surface, and what is the total energy of the object at infinity, or very, very far from the Earth's surface. So the total energy, which is composed of kinetic energy plus the potential energy. So the total kinetic energy is half mv squared, and the potential energy is g m over r. And remember, at infinity, the total energy of the object will be zero at infinity. So if I solve for the v, it will be simply equal to, this mass and this mass will cancel out. It will be simply equal to 2 g m over r. And in this case, g is the universal gravitational constant, and m is the mass of the Earth. I would write down here the capital R because we are doing the calculation from the Earth's surface. So it will be Earth's surface here. That is R. G is the universal gravitational constant, m is the mass of the Earth, and r is the radius of the Earth. Okay, so that is the escape velocity equation. So now, if you have to calculate the escape velocity, all we have to plug in the values. So the mass of the Earth is given, which is 5.96 times 10 to the 24 kilogram. The radius of the Earth is given. The universal gravitational constant is given. All we have to plug in this equation, all the numbers. And if you do the calculation, that means the number you will get will be 11.2 kilometer per second. And again, as I mentioned here, if you throw an object at 11.2 kilometer per second from the Earth's surface, it will never reach back to the Earth surface here. Okay, so this is it from this video. If you have any questions, any comments, write down in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.